Okay. So we have some websites that are static. Those websites typically are just to display information, right? Um, and then we have the ones that are dynamic. Those ones displays different things. Like maybe as you log into Google now, you see your own name. Welcome, Lazy Guy. Welcome, James. Welcome, John. Is showing is dynamic, showing to displaying different things based on the user. So and that is dynamic. Now, like I said, those ones now you could have the database, get data, build data, take templates. All these ones here now is the back end, how it would handle it. But the static one, you can just have HTML, CSS, and JavaScript kept somewhere. Once they ask for your website, they'll just go there, they just show you information. Like maybe you're going to see someone's website, like we too, we can even build our own personal website, right? So just come to your website and see what you can do. That's it. It's just a static kind of um, arrangement. But when it comes to dynamic, it's not just information. We're talking about an application that is on the web. It could do many things, right? So the next page here now, we have API and dynamic. Dynamic now, which is the one we also um, do primarily with Flask, is where you, like we discussed in the previous um, page, you have this build website is like the app, right? Based on what happens is to get data from the database, arrange a response, take some template. This template has like HTML, CSS, and JavaScript and send to the browser. The browser will display. For example, you try to sign in and you're successful. You then see welcome, John, right? Why is it welcome, John? It's because the the app have seen that, oh yes, the credentials are okay, you're authenticated, it will not send this page. If you're not authenticated, it will send this other page. Okay. When you're signed in, there are some things maybe someone that is signed in can see. Someone that have not signed in cannot see. If you're talking about maybe a post on something like Twitter, Facebook, when it is you that own the post, you can see some extra functionality like edit, you can see delete, because the app is able to recognize that you are the owner and you can do those kind of actions. But the same post, if another person views it, the person cannot edit it. He can't delete it because he's not viewing it as from a position of I'm the owner. It's someone else that owns it. So the app is able to make all those judgments and show those things, which is how it was built. People built it, people wrote it, right, to do like that. Now we have that server side render. Everything is from the server. Then we have the one that is client side render. This one now is the one we talk about API, application programming interface. So this one, you make your application to respond with information based on the request. It will just respond. It will not bring all these HTML, CSS, and JavaScript. No, it will just bring the information. For example, if it's an API to log in, if you provide the correct credentials, it will just send response in a format, JSON format, majorly. So in that format now, it will just say authenticated, yes, some information that another application can use. Okay, another application can use that information and know that you've been authenticated. So this one now is this API is just built, for example, to be authenticating people against when you register, you put yourself in a database. When you want to authenticate, you just call on this this API to authenticate, and it will just check and give you a response that is just like text, no CSS, no HTML, just information, JSON format information. Now, based on that, another application can consume that data and use it. So if you're doing this API kind of app, your app will send information to the API and get a response in JSON. And based on that response, it will know the page to display, but it's not sending this page from the server. The server is just giving it information. Then you can have another server that holds your app that will build your website with the templates, but they are not from the same location. Okay, I hope that's clear.
Yes.
So if you can hear some people say there's an API, and you just go to the API and get some information from that. I hope we'll have the chance to also look at API a bit towards the end of this course.
And so what sometimes like there are some situations where people can access let's say an IT person can access a customer device using the IP address, correct? Is it possible?
Yes,
Yes. Okay.
all those, all these like hackers now, those kind of things.
Okay, that's what they do. Ah.
If they can use your app, IP trace you. Sometimes Buhari went and stopped us from doing, those of us in Nigeria stopped us from using Twitter. What were people doing? They were going to get apps that would change their IP. So the app would, when they want to enter the internet, the app will bring an IP address for somewhere in America and kind of replace their IP with that IP, right? So even though all the IP address for Nigeria is blocked, the
America
the
won't open.
the back end will see them as if they are in America and then allow them to see content because the Americans are not blocked. So there are some service providers that give such service. They will be changing the IP. So there are a lot of people do with all these things, like those that hack, cybersecurity issues, and so on and so forth. There's a lot on that side. Okay, I hope that answers your question.
Yes, very well.
So one beautiful thing about API is when you create an API. Okay, let me try to explain this now. When you have this kind of website that is server side rendered, if you build it, you have to build it on the server to respond to maybe a cell phone, a computer, different devices. If you did not build it to respond to any type of device and that device calls it, it will give it the normal default one that will be like maybe for a computer browser. It might not show well on that device. Okay. So everything is done from the server side. But in this one now, you can have an API. It will just bring data no matter who is consuming it. Like look at this now. You see, one API, if it's a browser, it will give the same information. If you bring mobile app for iOS, it will respond. It will be giving out data in this format. See this picture here. This is that JSON format. Okay. This person now made a request to this API endpoint asking for my course data. This is the response. It's just like this. It gave ID 1. This is the name of the course. This is the rating of the course. The second course here is ID 3. This is the name of the course. This is the rating of the course. The second course, maybe this person is someone that makes courses. So the second course is 4. You see the name of the course and you see the current rating of the course. So this is what the API just give back. Okay, then you now build your application for maybe Android. The same Android application will call this API. The one that's for browser will call the API. An example of something that is built like this now is WhatsApp. You can take your WhatsApp now, put it on your computer. Your computer is now like using the browser. Pam, it will go collect information, no problem. You can take the WhatsApp to the iOS. the iPhone, right? It will still go the same data. When this data come, you build applications in um these different either for the browser, for the mobile app, or maybe for Windows, for instance, or Mac, and so on and so forth. And if you just take the data, see all of them are receiving the same data, then the app will use it the way it wants to use it. So the server is not the one that is trying to determine which device to feed. Rather, it will just bring the data. Then the front end will just build the data, build the app for like this same WhatsApp we're saying now. On Android, you have WhatsApp. On iOS, you have WhatsApp. All of
Mm.
them now, you see, they can be collecting the same data. You have your WhatsApp open on your phone, your WhatsApp open on your computer. There's no conflict because they are both calling the same API and it's just giving them the information they need to continue their life. But if it was the server side render, whenever you use your phone, the server will need to prepare and know that, okay, this one I'm sending it to phone, it will not prepare for phone, send. Whenever you go and query it for desktop browser, it will do like that. So this is kind of like the new modern way to be building things. You make APIs and call them and consume them with different platforms. Okay. So does
Yeah.
anyone have any questions so far?
Yep.
It sounds interesting.
Yeah, it's interesting. So now let's go back a
Yep.
bit. This Flask course, now this is the one we are going to do. Okay, we'll start from here. Where we'll build a
That's
server side.
the front end.
No, no front end here. We'll build a server side rendered application. Okay.
Okay.
That when the user makes requests, we will now send him the necessary HTML, CSS, and JavaScript pages for him to have what he wants.
Okay.
Okay. Which is now the front end engineer also will build his own, but everything will sit on one server and come from there. But when you're doing this API, you don't really care about the front end. You don't care about it. You just build an API and send out data in JSON format. Now the front end people, anyone they want to use and consume this data that you have provided is up to them. The back engineer is just like separating the tasks clearly. But here in the server side render, as you're building the application, this front end is working with you. Okay, that we are working hand in hand. Okay, when the person is not able to log in, this is how I want the login to be. The front end also will be working. So if you are working together. But in API, once it's not logged in, I'll just see these are the data I'll send out. The front end now, they'll now go to the API, consume it. When they call on the API, based on the data you send, they will now develop their own front end. Nothing concerning you. This way, APIs, you can even build your own API and people can be calling upon your API and using it for many things. And maybe you could, if your API it has value, you can sell it. For people to call on your API, they will pay you. For example, someone now that goes and writes an API that can convert English to Igbo or English to Hausa, right? You can write that API now if your API is very good in doing that language conversion, right? You just perfect it. Your own is very, very good. You find out that somebody now, even Google, may want to do a conversion of their applications or stuff on their device to Igbo language. I'm just saying, for example, because I know Google they're already doing it. I don't even know how they are doing it.
Mm.
Maybe they are even buying that conversion from an API someone have already built. So they'll just call your API. You will give them a way to authenticate and get authorization to use your API. They'll of course pay for it. You give them some token. Then because they are authorized, their applications can be when you say convert from English to Igbo, it's not really the person that built the application now. Let's forget about Google. Let's say if me and you are building an application, We need the application now to go and change some display information to Igbo. But we are not speaking Igbo like that. If there's an API that we are sure this API can do a good conversion, we can go and sign up, get authorization to use the API. Then our application will be, anytime the user wants to change the language, our application will just send all the English to that API endpoint. The API will do the conversion for us. We didn't build it. We just built our device and we call on that API. When we want French, maybe if the API can do many languages, the API will just be doing all our conversion for us. So if you're building an application today, instead of you to build everything by yourself, say you want to build the French, the German, so far as you can just convert the language, there are APIs you can call on that will give you good language conversion, and you just consume them and use them in your own. The same thing goes with say weather app now. If I'm building an application and I want the application to be able to tell the current weather of the city you're in, I don't need to go and build my application back end to be able to interpret weather, do all the weather stuff. It's not my own profession. But now there are people who have APIs that have information on weather, right? We'll go and buy from them. They will just give us the access to the API. We'll query the API. Our application will be querying the API to give our users live weather information. We're not the person that brought the weather information. We are taking it off somebody. Okay? That's how things are. So everybody now have their API you can get from them instead of you to go and build everything from scratch. You just use their API and life is good for you. Like I think InterSwitch now, for instance, if you're building an application that needs to collect money from users, you don't need to go and build how to collect money and everything. Maybe you can use InterSwitch. When you go and meet them, they have their API. They'll give you authorization to use it. You satisfy the condition. Then your user, when they want to make payment, you can call their own and they'll process it for you. Does that make sense? That's
Yeah.
APIs, different APIs
Okay.
like that.
Okay. Sorry, I want to find out from this API of a thing. Is it something? Who are the people that are responsible for writing the API? Is it a back-end application or a front end?
It's
And
back end.
secondly, okay, it's a back-end application.
Mm.
Okay. Is there a particular language that is meant for writing this API?
No particular language. You can use Node.js, which is JavaScript based. You can also use Python. And when you want to use Python, you can use Django or Flask, which you're about to learn, to also write the API. You can use PHP. You can use many languages to do it. Okay. And when you're calling upon an API, whatever language you use, not your business. It will always give out data in like that JSON format. You see, when this data came like this, it did not tell, there's nothing here that say Python. So if whoever built this API built it with Python, it's not your business. All you just want to know is, if I query this API, what information will it give to me? They will have a documentation. They will tell you, if you send a GET request like this is what you get. This is the proper way to send it to our API. If you want to build an API, you do proper documentation too, so that people can read and use it. You get the language they used to write is back end though. It's not your own business. Your own is, it will give you JSON data. This JSON data, any language you're using can take it in. Any other programming you're doing can take that JSON data. So with this now, you can even use Python and build the API, send it to C#. C# will come and take this data and do his own work. C++ will come take the same data, do his own work. That's why you can see different platforms can consume the same API.
Data.
Yeah. So once you build a good API that has good information, people want it, they'll come. And like recently, there's somebody that is doing something for football. data of African footballers in Africa. When the guy finished gathering all those data now, if you have data on all the footballers currently playing in Africa and all these British clubs or Spanish clubs want to buy African player or know about players, maybe young players in Africa, that kind of person that have built an API like that and has collected data and kept it there, all these people will pay and they'll just call on the API and they will see data of people. Yeah, they can use it for whatever they want to use it because they pay for it. Okay, so
This is interesting.
yeah, all of this now is
So
back end.
okay.
Go ahead.
Okay, so now after the deployment of how is it deployed?
So if you
This
build your API now, there are people that provide those such services. Like you can go and deploy it on AWS. You can go and deploy it on Google Cloud. And there are many other people that host. They can host your API for you. You pay them, if there's a fee, you put your files and everything there. Okay. So if I host it on AWS, for instance, what it simply means is I move my files, everything I've built to an AWS server managed by Amazon. That's how I simply in a computer somewhere with AWS. Because AWS now, they have high reliability. Okay, they have a way their own system is built, and many others too are like that. So that that data, whenever somebody wants to access it, you're sure it's just like 247 is there. Okay, once you've hosted it, any hosting platform host it for you. You can always, anybody can call. All these websites we are opening, they are already hosted. Now, when we are doing something on our computer, people cannot access it because we've not we can host it on your computer. You know, you can host it and point people to your computer when they want the information. But you see your small computer, before you know, you've shut it down. It's before you know, the computer have crashed. So if you host your application on your own computer and all those things are happening, people cannot do when they want to do. So people like that, companies like that, they are now provided that service. That's their own service. They'll make sure the computer is up and running. They'll make sure your data is always there. They'll give you their promise, right? In the contract you sign with them, that this availability they are going to promise you, blah blah blah. They'll put it there. Like me, I know some things about AWS, so I can speak small about them. For example, they have what they call availability zones, right? And just like we have regions and availability zones. Availability zones are like data centers. Data centers are a kind of building that hosts all those kind of computers. It's a physical place. There's constant light. The power for the data center is ensured. Maybe there's standby gen. If something happens, even though it's in America and there's an earthquake and the power plant supplying them gets cut off, that data center has a generator that immediately will peak. You know, those kind of things are there. So just to make sure that it's always on. Okay. And then they can, people like Amazon now, they can, in a region, they may have different data centers where they replicate data. So you can have it in a data center in, let's say, Lagos, and that data center could be in Port Harcourt, and that data center could be in Abuja, for instance. And if the one in Lagos shut down, your data is also replicated in Port Harcourt. Okay. And they have a system of managing these things so that if that one in Lagos, maybe somebody go and bomb it, you just scatter. When somebody tries to access what you hosted on their service, it will pick from the one in Port Harcourt, which is a replica. Okay, so when it goes to system engineering and all that, you see the way they configure all these things. Okay, and they're working. And one thing I would like to tell people to begin to open your eyes to is cloud computing. Very interesting when you begin to know what they are doing and the capabilities there. Right.
So what is it all about?
It's all about like this thing I'm telling you about Amazon, for instance. They are able to build one computer and share it. So in that computer, you can go and meet them that you want a computer of 1 terabyte for your own stuff. You can pay for it. It's like partitioning computer. And in that your partition, it's a hard disk, so it's a hard disk, let's say now in a computer. Imagine in my laptop I have a hard disk, but I am able to give you, if my hard disk is 1 tera, I can sell to you 5 gig. I can sell to another person 2 gig, another person 100 gig for my 1 terabyte, something like that. All of you can come in and do what you want to do. Install whichever operating system you want to install. Right? So those are that kind of cloud computing. How does all this thing work? How are they configured? So when you now begin to delve into that area, you now begin to see a lot of things. In terms of security, how are they secure that somebody cannot just jump into another person's own? Things like that. If you start studying it, you'll be amazed at what people are doing. You get many things happening there. It's an interesting one. People get jobs there and they don't really need to know all these programming languages. That side now, they may need to, there are some kind of scripts they will be writing, configuration files, which is different from all this programming we are doing. Okay, anyway, that one is there.
So the cloud computing is not necessary must know Python. It's not necessary must know HTML.
It's not necessary, but it's an added advantage because even there in the cloud, for instance, in AWS too, they have what do they call this now? There's some kind of computing and programming that you can do there, but you can use any language you know to do it. I forget what they just called that one now. There's one that came to my mind. It's there. So, but if anyone you know is still good, even if you don't know, you can become a cloud engineer for a company. You don't even have to write any programming language. Because what they do is different from programming. Okay. So now we have talked a little bit about the internet, web programming, web development, how the web works. Just a little. Okay, there are many things in there. At least our eyes can now begin to see that, oh, we are going to do something about building a website, getting the necessary template, working with database, you get and rendering it to the user using Flask. Okay. Then there's something else I want us to look at before we end today's class. Do we know about virtual environment?
Virtual.
I think I've heard of it.
No, I don't know about it.
I've heard about it.
Okay, let's see if in the time we have, we can quickly do it. So I'll create a folder now. Let me open Visual Studio Code.
Is it the same thing like virtual machine?
No, don't worry, I'll explain it now.
Okay.
Can you
Because
see
I
my VS
remember,
Code?
yes.
So, okay, now, this is my VS Code in a folder. The folder is empty. No, the folder is just the Flask class. Okay. If I put a Python file here now and run the Python file, it is going to run in Python installed on my computer as a whole, because I installed Python on my computer. Now, virtual environment gives us the ability to create another environment for doing our work in Python that is different from the environment in my computer. Okay. Now I just type, for instance, on my terminal. Can you see I type pip freeze?
Yes.
Okay. Now when you run this stuff, you would see every package that you have installed on your computer in Python. So if I look at it now, see there are many things me have installed, I've used for different stuff, right? There are just many. Now, if I want to build an application, I may not need all of this. I may even need something that is not here. And with each of these, there are versions. When you talk about this one now, you see the version is 4.2.0. This one, the version is 23.1, blah, 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 like that. Now, when you're building an application, any module or package that you use, you are using a particular version, right? Maybe you downloaded it today, you're using the version of today. You build your stuff is working today. Tomorrow, they may change the version. If you run your code with the new version, it might be an error because they have introduced some things and changed the way some things were. Okay? Now, if you build it in a virtual environment, you can then specify the particular version you want to use. In that virtual environment, it will be different from the version I have in my computer as general. Okay? In the virtual environment, I will have certain packages are installed there. So it's like creating another kind of environment for your Python virtual environment. That was called. If I want to build an application, I will create a virtual environment, and then I'll build my application, install everything I want to build the application there with the what they call it now, the version. When I finish, I can easily do freeze and pick out all the versions of everything I used, and I can then put it in a file like requirements.py. So if you want to run my application, there will be that requirements.py that will specify all the packages I used and the version. So if you want to run my application, you need to install those versions. Then my application, you're guaranteed to run. If you install a more recent version, which is different from what I built the application with, you might have challenges because things change. The way we do things change in programming when they release new versions. These changes, they are not usually huge. Even Python itself, Python has different versions. I hope you know. Every day they are making improvement to Python.
Yes.
And different versions, different capabilities. So it's changing over time. So if you build something with a version of Python, in the newer version, the thing may not work as you intended because they changed some functionalities. Okay. Part of maintaining a code base is about these versions. When these versions are released based on what you use for your code, the engineers go ahead and test their code with the new version. And if they need to make modification, they make modification. Then they also bring out a new version of the application with the latest packages, because as packages come out, as technology is evolving, that's why packages are changing. Okay. For instance, when you go to Apple, at a point they'll tell you they're no longer supporting some iOS. If you're using all those old ones now, you cannot download updates. Why the new ones are downloaded? Because they cannot continue to maintain all of them. at a point they have to give up some. But you may want to run something on an old version, right? You need to know the packages that were in that old version to use it to run that stuff. So virtual environment gives us this opportunity. So now let me just create one and you see how we create it. Any question?
It's understood. Continue.
No, for now.
Okay. You can see Python-m VMV. I can say my VMV. So the code for creating virtual environment is, you can say Python-m then VMV. So it's like saying Python make virtual environment. Then the next space, then the next thing you type is what you want to name your virtual environment. Some people can name their own, like the VMV. So you can see Python-make VMV. What I'm simply doing, I'm naming my virtual environment VENV. So if I hit enter now, in my flags folder, you can see there's a VENV. Okay, let me run this command again. Okay, it's still okay, that's finished now. And let me run the command again and do my VENV. Hit it enter. So you see there are two of them. Okay. So what I'm trying to show you that what you type here determines the name of your virtual environment. Let me just delete one. Let me delete this one. So here we go. I have a virtual environment, my VMV. It's there, but if I run any Python file now, it will not run in my virtual environment. I need to activate my virtual environment. Depending on whether you're using MacBook or Windows, the way you activate it differs. Okay. Now, just to digress a bit, even when we're talking about virtual environment, you remember you can always just Google it. Virtual environment. Let's see. Okay, yeah, for Python now you can see VMV. In case you forget how to create it, or so you can see creating of the virtual environment. You can see what we just did, Python-m VMV, then we choose the name of the file. You can also add the path if you want to be that specific, but I'm creating it already in the folder I'm in, so there's only for path. I just put the file name. Then you could see how to activate it. This one now is majorly okay, yeah, it's Windows, so you can see how you do it in the Windows. You put the name of the virtual environment /scripts/activate. Sometimes you don't even need to put this .bat or this. But let's activate our own now. You can read more about it there if you want. So if I want to activate mine now, from what we saw there, the name of my own is my VENV/scripts/activate. So when I hit enter, I've activated it. How do I know I've activated it? Can you see this here? In a bracket, you see my virtual environment name. Can you see it?
Yes.
So it's been activated. Now that it's activated, let's run pip freeze and see. Can you see that there's nothing? Right?
Yes.
There's nothing because the virtual environment is empty. It's a new environment I created. But if I come out of